Welcome everyone, Professor Bright here, and we're going to get our studies today started by talking about some base functions, and then eventually we'll talk about transformations towards the end of the video. And so you can see in this section we really want to just be able to recognize and apply transformations to functions. And so what that's going to involve is we have to talk about base functions. I call them parent functions sometimes, so just know both pieces of language. And then we're going to talk about the transformations using function approaches. So from algebra, from graphical, from tabular, and then of course we gotta give it a name, so that's more the descriptive. So and then we're just gonna do it. So here we are, base functions. You absolutely need to know these. Like, I don't really recommend flashcards in math, but if you don't know what a constant function, linear function, all these functions look like graphically and in a table and in an equation, you need to know these. Memorize these somehow. Okay, so constant function. When we use that language, generally what we refer to the function looking like is something like y is equal to k. So y is equal to a number. Generally, since we use the language of function, we would actually say f of x is equal to k. But I digress. So what we would see is something like, if we have an xy table, all the y values would be exactly the same. They would be the k value that appears in the equation. So graphically, what we get is at the vertical value of k, we get a horizontal line. Ain't that fun? Okay. Linear function. When we use that language, that's something like f of x is equal to x, or generally y is equal to x, same idea. And we just finished our study with these, and so what we would see is something like, if we put in 0, we get out 0. If we put in 1, we get 1. 2, we get 2. Negative 1, we get negative 1. And like that. So then when we graph it, I'm just going to do a quick little sketch here. You get a line, and then we know its slope, we know its intercept. Oh, that's kind of a bad point right there. So we get a nice old line here. Okay. Next type of function you need to know is quadratic. Okay, when we use quadratic, that's going to look, at least the parent or the base function is going to look like y is equal to x squared, or f of x is equal to x squared. Now there is a more general model, which we'll get to eventually, but this is the base graph. And so we see we end up squaring whatever the x is, so we get 0, 1, 4 for 0, 1, and 2 respectively. And then when we square negatives, remember they become positive. So graphically what we end up with is something that looks like this. Okay, so I just plotted those points, and I'm going to connect them with a curve, and you might recall the shape of this graph is called a parabola. Okay, so there we go. It's a U. Make sure it's rounded, not pointed. Moving on. Cubic function. Well, cube means to the third power, so we're going to have our function looking like f of x is equal to x cubed. And so when you do this, you end up getting these. Now, when you have negatives and you have an odd power on them, that just makes them still negative, so that's why we have that. And so when we graph this, I'm going to omit plotting the points precisely. You sure can if you want. What you end up with is something that looks like this, and so it's going to be more of a, I think of this one as a snake. Okay, having that, so decreasing as you go to the left, falling as you go to the left, and rising as you go to the right. Okay, now along with these, so we talked about a quadratic or a squaring function. Cubic function is to the power of 3. We have now their roots. And so this is going to look like f of x is equal to, it says square root, so you write a square root of x. Okay. And then in some software, if you need to, you can remember that exponents are, or radicals are fractional exponents, so this is 1/2. And so when we do this, we have to take the square root of all these. Square root of 0 is defined. It is 0 if it's in the numerator, which this one is, 2 and 3. So again, I'm not plotting points precisely, but this is the general shape. So let's see, 0, 0, 1, 1, 4, 2, and then 3, and then 9, 3. So we get this, and really you can think of this as like a parabola turned on its side with half of it, with it cut in half. That's really what a square root function is. We'll come back to that when we talk about function inverses. Cube root. Okay, f of x. Now, so it says it's a root, it's a cube root, and then x. And then again, remember, you could represent this as x to the 1/3 power. And so here I picked some nice values. Again, these are the ones that I'd recommend remembering. You end up with -2, -1, 0, 1, and 2. So then when you do this, you get 0, 0, and again, I'm not plotting precisely. -8, -2, something like that. And so this is more like that cube function that we saw, the snake, just turned on its side and, well, maybe reflected a little bit. Okay, so that's what a cube root function is going to look like. 2 more functions, and then we have completed our base functions that we need to know. When we use absolute value of x, boom, put x in absolute values. 2, 1, 0, 1, 2 for the table. And when we do this, we get a nice and a very, very nice v. Now this looks similar to the squaring or the quadratic function, but it's just going to be a sharp point at the place where it turns. Reciprocal function. Now this one could give you a little bit of grief, mainly because you might not think to call it this. You might want to call it the inverse, and I understand, but inverse function is something very specific in math, which we'll get to later. So reciprocal function, and so f of x equals 1 over x, and so this just says, okay, this is going to be -1/2, -1, -2, okay, because you're doing the reciprocal, and then 2, 1, 1/2, and so the thing that might give you a hard time is that when you graph these, it always comes in pairs. So you end up with, and again, I'm not plotting precisely, but you're going to end up with a piece here in this case, quadrant 1, and then you're going to have another piece here in quadrant 3. So you get something looking like that. Okay, so make sure to look for both pieces. Okay. Now, these base functions that we just worked with, we don't always see them like this. Like when we studied linear functions, we had y is equal to mx plus b, right? We didn't have just x. So when we look at something that's a little different, we call that a transformation of that graph. And generally speaking, what the number of transformations we can do to a function is limited according to this general transformation model. Okay, so remember, f here is your function, and then it says you can change the input in 2 different ways, and you can change the output after you've found the y value. So we just need to figure out what a, b, c, and d do, and that's really the focus of our videos in this section. So next one we'll talk about the effects of c and d. Later we'll talk about a and b, and then we'll put them all together.